Welcome back, everyone. Today, we're going to be taking a deep dive into a question that's really interesting, I think, for the future of air travel.
Absolutely.
Will hybrid electric planes really be a thing by 2030?
Ooh.
And if so, what kind of plane is going to be, leading the charge?
It's a fascinating question, especially given, the aviation industry's goal of reaching net zero emissions by 2050.
Right.
Hybrid electric propulsion is seen as a potential, bridge to get there.
Exactly. And we've got some really in-depth research from Georgia Tech and NASA to help us unpack this. They really dug into the nitty-gritty of how these systems might work in the near future.
Yeah.
Focusing on two main aircraft types. Turbofans, those big commercial jets, and turboprops, which are often used for kind of shorter regional flights.
Yeah, the study wanted to analyze which of these two architectures would benefit more from hybridizing their propulsion systems.
Right.
But there's a catch. We're dealing with emerging technology here.
Right.
And predicting how this will evolve in the next few years is a challenge.
Yeah, uncertainty is a major factor here.
Absolutely.
So how did they even approach such a complex problem? How do you...
So they use three different approaches to analyze the impact of this technological uncertainty.
Okay.
The first one is deterministic design optimization, or DDO.
Okay.
Think of it as a best-case scenario approach. So
okay, sure.
they assume that all the technologies involved would reach their most optimistic projected state by 2030.
Okay, so it's like everything goes perfectly according to plan.
Precisely.
Yeah.
Now, the second approach is called design optimization under uncertainty, or DOU.
Okay.
And this is where things get a little more strategic.
Okay.
Instead of assuming a perfect outcome, they looked for designs that could perform well across a whole range of potential technology advancements.
Right.
So imagine designing a plane that can handle any curveball technology throws at it.
I see. So it's almost like you're hedging your bets against the unknown.
Exactly.
Okay.
And then the third approach is called uncertainty propagation on design optimization, UPDO.
UPDO. Okay.
And this one takes things to an even more granular level.
Okay.
So imagine looking at every possible combination of technology advancements.
Wow.
And redesigning the vehicle for each scenario.
Oh, okay.
That's UPDO in a nutshell.
That sounds incredibly thorough, like you're creating a custom-tailored plane for each possible future.
Yeah.
Okay, so with these three approaches in hand, they started by looking at turbofans, right?
Right.
What did they find?
Okay, so here's a truly remarkable finding. Even with all the uncertainties involved, over 95% of the simulations conducted showed fuel savings for the hybrid electric turbofan.
Oh, wow.
Compared to a conventional Airbus A320.
Okay.
On average, we're looking at about a 1.8% reduction in fuel consumption on a typical 900 nautical mile mission.
1.8%?
Yeah.
I mean, that's good. It's a step in the right direction, but it doesn't sound like a game changer. Didn't you say that one of the approaches resulted in almost no fuel savings?
You have a sharp eye for detail. That's right, the DOU approach.
Okay.
The one focused on designing for robustness across various scenarios yielded very, very minimal fuel savings.
For the turbofan.
For the turbofan.
Okay.
This suggests that, designing a hybrid electric turbofan that can kind of handle technological uncertainties might require compromising some performance.
That's a really interesting trade-off.
Yeah.
So what are the key technological hurdles for making hybrid electric turbofans a reality?
Well, the research pinpointed three technologies that have the biggest impact on fuel savings for this type of aircraft.
Okay.
First, there's the battery cell-specific energy.
Okay.
It basically refers to how much energy a battery can store for its weight.
Oh, okay.
The higher the specific energy, the more power you can pack into a lighter battery, which is, crucial for aircraft where weight is a major concern.
Makes sense. So lighter, more energy-dense batteries. What about the other two?
The second factor is the high-pressure compressor efficiency.
Okay.
And this refers to the efficiency of the compressor within the jet engine.
Okay.
So a more efficient compressor can extract more energy from the airflow, which directly translates into fuel savings.
Oh, I see. So it's all about squeezing every ounce of efficiency out of the engine itself.
Exactly.
The third factor.
The third factor is the battery pack factor, which essentially measures how efficiently you can pack the battery cells into a compact and lightweight system.
Right. Okay. So it's not just about the battery cells themselves, but also how effectively they can be integrated into the aircraft.
Precisely.
Okay. So those are the big three for turbofans. Better batteries, more efficient engines, and smarter battery packaging.
Yeah.
But Let's switch gears now and talk about turboprops.
Sure.
What did the research reveal about their potential for hybridization?
Well, this is where things get even more intriguing.
Oh.
Remember those 3 approaches to uncertainty analysis? Well, for turboprops, all 3 approaches consistently show significant fuel savings.
Oh, really?
We're talking about an average reduction of 25.31% compared to a conventional turboprop like the de Havilland DHC7.
Wow, that's a huge difference. 25%, that's a pretty compelling number.
It is.
Why does the turboprop seem to benefit so much more from hybridization than the turbofan?
Well, there are a few reasons for this.
Okay.
Turboprops generally have lower power requirements than turbofans.
Okay.
Which makes them a more natural fit for current hybrid electric technology.
So it's like trying to electrify a motorcycle versus a semi-truck.
Right.
Yeah.
The motorcycle is simply a smaller, less power-hungry machine,
Yeah.
making it easier to adapt to electric propulsion.
Gotcha.
The benefit space study for turboprops revealed that achieving these significant fuel savings mainly hinges on one key factor:
Well,
battery cell level specific energy.
okay, so battery technology seems to be the linchpin for turboprop.
It seems to be.
But you mentioned that inverter efficiency becomes critical when aiming for even bigger fuel savings.
Right.
Can you explain why that is?
Sure. The inverter is the component that converts the direct current, or DC, power from the battery to the alternating current.
AC.
Power, AC power, needed by the electric motors.
Okay.
You can think of it as a translator between the two systems.
I see. So the smoother the translation, the less energy gets lost in the process.
Exactly. And any energy lost during the conversion process means less power available for the aircraft,
Right.
which ultimately reduces fuel savings.
Okay.
The research found that as you target more aggressive fuel reduction goals, the efficiency of the inverter becomes even more crucial.
It sounds like everything's connected.
It is.
Improving one area, like battery technology, opens up new possibilities, but it also highlights the importance of other components, like the inverter, in maximizing efficiency.
Absolutely. It's a complex dance of interconnected technologies,
Right.
each playing a critical role in pushing the boundaries of what's possible.
This has been incredibly eye-opening. We've gone from the very basics of hybrid electric propulsion to unpacking specific technologies and their potential impact on different types of aircraft.
It's been great.
So,
Exploring these concepts with you.
yeah, and to our listeners, we hope this deep dive has sparked your curiosity and left you with some food for thought.
Absolutely.
But we're not done yet. In the next part of this deep dive, we'll continue to unravel the nuances of these systems and explore the broader implications of this research for the future of aviation. Stay tuned.
Stay tuned.
Welcome back to our deep dive into the world of hybrid electric aircraft.
Yeah.
Before we move on, I want to touch on something you mentioned earlier about noise pollution.
Yeah.
You know, fuel efficiency is obviously a major focus, but
Uh-huh.
are there any other potential benefits to hybrid electric planes?
That's a great question. And you're right. Fuel efficiency and reducing emissions are really at the forefront of this research.
Right.
However, reduced noise pollution is absolutely another potential benefit of hybrid electric aircraft.
I see.
Imagine quieter takeoffs and landings,
Yeah.
particularly for communities near airports,
Oh, yeah.
that could significantly improve their quality of life.
That's a fantastic point. Quieter skies would be a welcome change for a lot of people.
I think so.
Are there any other advantages we haven't even touched on?
Yes, there are also potential economic benefits as well.
Okay.
While the initial investment in hybrid electric technology might be higher,
Right.
the long-term operational costs could be significantly lower
Okay.
due to the reduced fuel consumption and potentially even lower maintenance expenses.
So not just good for the environment, but potentially good for the bottom line as well.
Right.
But let's get back to our comparison of turbofans and turboprops.
Okay.
We left off talking about how inverter efficiency becomes crucial as we aim for more ambitious fuel savings, especially for turboprops.
Yeah.
How do those benefit space studies we discussed earlier, how do they factor into all of this?
So those studies are crucial for understanding which technologies have the biggest impact on achieving specific fuel-saving goals.
Okay.
Instead of looking at all the possibilities for each technology, they focus specifically on the combinations that lead to significant fuel reduction.
Gotcha.
For turbofans, those studies highlighted the importance of battery cell-specific energy, high-pressure compressor efficiency, and the pack factor.
Right, those were the big three for turbofans.
Exactly.
What about the turboprops? Did the benefit space studies point to any other key players?
For turboprops, those studies revealed some interesting nuances.
Okay.
As you might expect, battery cell-specific energy remained a top contributor to fuel savings.
Okay.
However, when they analyzed scenarios targeting more ambitious fuel reduction goals, inverter efficiency actually became the second most important factor.
Oh, wow.
Even surpassing electric motor efficiency or specific power.
So the inverter really becomes a star player for turboprops when you're aiming for those big wins in fuel efficiency. Does this mean that other factors, like the high-pressure compressor efficiency, become less relevant for turboprops?
Not necessarily. While the benefits-based studies highlight the most crucial technologies for specific fuel-saving goals,
Right.
all those factors still contribute to the overall performance and efficiency of the hybrid system.
Right.
It's about understanding the relative importance of each component
Okay.
and focusing development efforts where they'll have the biggest impact.
That makes sense.
Yeah.
It sounds like there's a real art to optimizing these systems.
It is.
You know, you need to balance advancements in all these different technologies, but also consider the unique characteristics of each type of aircraft.
You hit the nail on the head. It's a complex engineering challenge, but that's what makes it so exciting.
Right.
There's so much room for innovation and exploration.
Yeah.
And the potential rewards in terms of sustainability and efficiency are enormous.
Speaking of potential rewards, before we wrap up this part of our deep dive, I want to go back to something we touched on earlier.
Sure.
The economic side of things. You mentioned some potential cost savings down the line.
Right.
But are there any economic hurdles or challenges that might slow down the adoption of this technology?
That's a crucial question.
Yeah.
And there are certainly challenges to consider.
Okay.
While the research indicates significant potential for fuel savings, the upfront investment costs for airlines to transition to a hybrid electric fleet would be substantial.
So even though there's long-term cost-saving potential, that initial price tag could be a major barrier for some airlines.
Yes, particularly in a competitive industry
Right.
where margins are often tight.
Makes sense.
Additionally, the development and certification of these new technologies require significant time and investment.
Right. So it sounds like a combination of factors will determine how quickly we see these hybrid electric aircraft take to the skies.
Yeah.
It's not just about technological advancements, but also about economic viability and regulatory support.
Exactly. It's a complex equation.
Right.
And predicting the exact timeline is very difficult.
Yeah.
However, the research we've been discussing provides valuable insights into the technical feasibility and potential benefits of this technology,
Right.
which could encourage further investment and accelerate its adoption.
Absolutely.
Yeah.
This has been a really enlightening conversation.
It has.
We've delved into the technical complexities, explored the potential benefits, and even touched on the economic realities of bringing hybrid electric aircraft to the mainstream.
Absolutely.
But our deep dive isn't over yet.
No.
In the final segment,
Yes.
we'll bring it all together and discuss what this research really means for the future of aviation.
Okay. Sound good.
Stay tuned. Welcome back to the final part of our deep dive into hybrid electric aircraft.
Yeah.
It's been quite a journey so far.
It has.
We've covered a lot of ground, from the technical details of these systems to their potential impact on fuel efficiency and even noise pollution.
Yeah, and we've seen how different types of aircraft like turbofans and turboprops might benefit from hybridization in different ways.
Exactly. But before we wrap things up, I want to take a step back and look at the bigger picture here.
Sure.
We've talked a lot about the potential of this technology.
Right.
But what does this research really tell us about the future of aviation?
It paints a fascinating, albeit complex, picture of what might lie ahead.
Okay.
While the research focused on 2030 as a target,
Right.
the reality is that the transition to hybrid electric flight will be an ongoing process, influenced by countless factors.
It's not like flipping a switch, right?
Exactly.
There are technological hurdles, economic considerations, and even regulatory challenges.
Precisely. But even with all those uncertainties, this research provides valuable insights. It highlights that hybrid electric propulsion is not just some futuristic concept,
Right.
but a tangible possibility with the potential to significantly reduce aviation's environmental footprint.
And it's not just about reducing emissions, is it? We also talked about the potential benefits, like quieter skies and even lower operating costs for airlines.
Absolutely.
Yeah.
Those additional benefits could play a crucial role in driving the adoption of this technology.
Right.
Imagine a world where Air travel is not only more sustainable, but also more affordable and enjoyable for passengers.
That's a very compelling vision.
It is.
But you mentioned earlier that turboprops might have an edge in the near future because of their lower power requirements and simpler architecture.
Right.
Does this mean that turbofans are, like, out of the race entirely?
Not necessarily. Remember, this research is based on specific technology projections for 2030.
Okay.
What if battery technology takes a giant leap forward in the next few years?
Yeah.
Suddenly, those limitations for turbofans might become less significant.
I see.
And they could emerge as strong contenders in the hybrid electric space.
So it's not a clear-cut victory for either type of aircraft.
Exactly. It's a dynamic field, and the landscape could shift dramatically as technologies evolve.
Yeah.
In fact, the research itself acknowledges this, emphasizing that their conclusions are based on a specific snapshot in time.
Yeah, that's a great point.
Yeah.
It kind of reminds us that predicting the future, especially in a field as complex as aviation, is always a bit of a gamble.
Absolutely. And this leads to a thought-provoking question for you to ponder.
Okay.
What if we move beyond the turbofan versus turboprop debate altogether?
Okay.
Could there be entirely new aircraft designs specifically optimized for hybrid electric propulsion that emerge in the coming years?
That's a fascinating idea. It's like we might be on the verge of a complete paradigm shift in aircraft design, driven by the possibilities of this new technology.
Precisely. And it underscores the importance of fostering innovation and exploring a wide range of approaches to achieve a more sustainable future for aviation.
This deep dive has been an incredible journey. We started with a simple question about the future of hybrid electric planes.
Right.
And we've ended up exploring a whole world of possibilities.
Yeah.
From technological breakthroughs to potential economic shifts, and even the very shape of aircraft to come.
Yeah, it's been a pleasure to unravel these complexities with you.
Yeah, it's been fun.
And to witness your genuine curiosity about this exciting field.
And to our listeners, we hope this deep dive has sparked your own curiosity and provided you with a glimpse into the future of flight.
Absolutely.
The world of aviation is on the cusp of a major transformation.
Yeah.
And hybrid electric technology could very well be the driving force behind a more sustainable, efficient, and enjoyable way to travel the skies.
Keep exploring, keep questioning, and who knows?
Yeah.
Maybe one day you'll find yourself boarding one of those whisper-quiet hybrid electric planes.
I hope so.
Soaring through the sky with a much smaller environmental footprint.
That's the dream.
Until next time.
Until next time.